Good morning, good morning, my dear friends. Good morning, my dear 12th students. Missing you all very badly. Your smiles, your noise, your energies, everything missing so badly for months now it has been. And now, at least, I'm happy to meet all of you through our virtual classes. And in the description box, you will find the contact numbers of all your teachers. And hope at least you will call all your teachers on these contact numbers and share any of your good news from your side, from your family. Now, at the outset, I would like to congratulate all of you for the recent results of your 11th. Congratulations to everyone. In fact, examination will definitely prove for everybody our areas of strengths and our areas of weakness. So one more time, after 10th board examination, you have given 11th examination. Hope all of you got your areas of strengths and areas of weakness. So now it is again a time where we improve all our areas of strengths a bit further and also take a look at our areas of weakness. We try to eliminate them, minimize them, whatever way possible. Try to do it with the help of all your teachers, your college system as a whole. And now, coming to our 12th class. Today onwards, we'll be meeting for our 12th class syllabus. It is a comprehensive and detailed classroom that happens now. Now, as usual, in your 11th physics, you have seen part 1 and part 2. Here as well again you will find part 1 and part 2 books, such that in the entire part 1 textbook, we will have this electricity and magnetism topics. And in part 2, we have the topics of optics and modern physics. So this is how our second year syllabus will be dealt with. In these two parts, I will be meeting all my student friends with part 1, the electricity magnetism part. Really, it will be felt as again a new beginning for most of the students. Yes, certainly it happens. But do remember, we have mentioned few important things during our 11th class. That 12th class, no new physics. Most of the second year physics is again a kind of new or old wine in a new bottle. Yes, it is old wine in a new bottle like. I told you, remember, in physics we have 5 or 6 concepts, right? First let me list out all those concepts which makes the subject physics. To begin with, of course, the understanding, the idea of the units, how to write a unit, what a unit actually expresses, and how we can relate different units. Number 1. Second one is the biggest topic, I should say, as the language of physics, vectors. Vectors, vector analysis, vector representations. This is number 2. Third one comes motion topic. Different types of motion. Different types of motion. To begin with, the simplest, the straight line motion. Then again continued with the non-linear motions, the 2D motions, and then going to rotatory motions, and then oscillatory motions, etc. Different types of motions. Fourth one should say, this fourth topic is what is the heart of physics. That fourth topic, or fourth concept of physics would be force. Force. Different types of forces in nature. Number 5, the idea of work and energy. The idea of work and energy, different forms of energies, work, the relations, so on. So these are the 5 topics. Then comes the sixth one, the idea of wave and wave motion. So these six form the entire physics, starting from units, then we said understanding of vectors, then motion, force, work energy and wave motion. In fact, all these six concepts we have learned with some details and sometimes more details in our first PU as well, completely. In the first PU, these are the things that we have dealt with. Now the question is, what happens about the second year's syllabus? Second year syllabus, we have to make use of the same concepts. The same motion will come across, the same concept of force we will see, the same concept of energy work will be there. Nothing new about second year physics. The name of the units you will find different, 15 or 16, whatever is there according to NCERT textbook. Those many number of units we will observe. Again 2 books with 16, 17, 18 number of units according to the textbooks. But barring very few exemptions like the concept of ray optics, somewhere in the like current electricity, except that remaining 80 to 90% of our second year physics will definitely be again the same physics with the 6 concepts. We will introduce new units and new terminology, but they are once again the same. They are all either related to motion, related to force or related to energy, and of course the idea of wave and wave motion. So second year physics is really a very easy physics, I should say, because we are already dealt with all these 6 concepts and we are now ready with using all that understanding here. When I have told you, it should be the case of understanding. It is not that memory of those concepts or definitions that we have told in first year. Memory does not help, so it is proper understanding of these concepts. Now, let us see what is our 12th class part 1 physics to begin with. Class part 1 syllabus, let us begin with. Our first topic would be on electricity. This electricity also we study in 3 to 4 separate titles. To begin with, electrostatics, then current electricity, then electromagnetics, afterwards electromagnetic induction, and afterwards alternating current. So these are all the part of our part 1 syllabus. Now again we have subunits in each of these titles. Now we begin with our electrostatics. Right. First let us see some important aspects about our study. See, we know that physics is the study of matter and energy. Matter in all its forms and energy in all its forms. When we say matter, matter has 2 important characteristics. Matter has 2 important characteristics. One is mass, and the other character is what is charge. So these are the characteristics of matter. Now, mass, the characteristic of the mass was the subject matter of mechanics, which we have studied in our first PU. So mass, subject matter of mechanics. First PU, all part 1 and even some of the part 2 syllabus was also mechanics only, right? Complete about mass and its consequences. Now here comes the another characteristic of matter, which is charge, and this charge is now the subject matter for an extensive subject called electricity. So this is how we now define first charge. Now what do you mean by charge? To define charge, it is very difficult. Rather, in the simplest way, we can give one statement that charge is the fundamental character of matter. Charge is the fundamental character of matter, and in fact, the charge is the building block of the matter. When it comes to the case of 20th century, from the 20th century, we know what is this matter is. Matter made up of atoms. The name atom was given with a significance. You know what is the meaning of atom? Atom means indivisible, which cannot be divided further. If matter is cut into very small entities, that last element which we get, which is not divisible further, that they have felt and given the name atom. But today we know that the name given to that name atom has no meaning, because in the beginning of the 20th century it is proven that atom is divisible. Atom is made up of, again, inside nucleus with protons positively charged, neutrons without any charge, and outside the nucleus negatively charged electrons. Therefore, now we can say charge is the characteristic of matter, and also charges, which we call fundamental charges, which we are now coming to. Fundamental charges are the building blocks of matter. Now, is that okay? Charge is the fundamental character of the matter, and charge are the building blocks of matter. Now, let's just go back to your high school level knowledge. There, you have studied about these topics with some origin. How? Supposing, take the case, I have, this is a plastic rod. This is a plastic rod, and rubbed with either silk or wool material. Plastic rod rubbed with a silk cloth or a wool cloth. Then, to find that interesting thing, we will now take two plastic rods. See, this is how I have taken two plastic rods. Both happens to be plastic rod, and both are rubbed with silk cloth. Both rubbed with silk cloth. Now the observation is that when they are brought closer, when these two plastic rods are brought closer, it is observed that they tend to move away from each other. This tendency of moving away from each other is what we call as repulsion. Suppose if they show the tendency of coming closer, what we call attraction. The same we see with other people. With some people, we feel the tendency and we want to go too close to them. We want to attract them, or we attract someone, and at the same time, we know we want to move away from some people. That's what repulsion. Here, the plastic rods both are identical material I am taking and rubbed with identical material like silk. They show the tendency of repelling. Whereas, supposing next time what I do is that one plastic rod, another one, let us repeat this experiment, sir. Second part of the experiment. This time, yes, plastic rod, and the other one we have taken as glass rod made up of glass. Now, this one rubbed with silk cloth, glass also rubbed with silk cloth. Earlier, these two materials were same, plastic, or glass. Now this time, one is a plastic material, the other one is glass material. Now both are rubbed with silk cloth. Again the two rods brought closer. The observation is interesting. This time they tend to move closer to each other, that is showing the tendency of attraction. Now here comes a question. Why this tendency of coming closer or moving away from each other? See, anything begins with observation. And that observation with experimentation, they will have some inferences. We will draw some conclusions. Now, what are the conclusions that we have taken? Same material, rubbed with the silk or wool cloth, then coming closer, repel. Another conclusion is that if they are different material, rubbed with same cloth, likewise. So, like this, any observation with the repeated experimentation, coming to some firm conclusions, and then there the analysis will begin. So after huge experimentation, and according to these conclusions, over a period of years, now people realize that what changed, because generally when we get two plastic rods closer, they don't show any tendency of moving away or coming closer. But now these rubbed rods, why they are showing that behavior, and now here a conclusion is drawn that during this rubbing, what we call rods rubbed with cloth, during this rubbing, some changes happening in the rods. That change is making the rods to attract or repel. Now, that change is due to the property of charge, that is the final conclusion. Right? Earlier we said, whenever we take any matter, matter has one characteristic which is mass, the other characteristic is, yes, similar to mass, matter has one more character which is called charge, such that when this rubbing is happening, there is change in the character of the charge of the matter. Remember, I repeat my sentence. During during rubbing of these rods with silk cloth or wool cloth or fur, whatever material we take, now comes the important statement of during rubbing or while rubbing or because of rubbing. Now, for any observation, the conclusions that are drawn are very, very important. Before drawing the conclusion, very, very long experimentations will be done, repeated experimentations will be done over a very longer period, and then conclusions are drawn. Now, what is the conclusion that you can take from these rubbing experiments? That because of the rubbing, there is a change in the character of that material, the plastic material or glass material that we talk about. There is a change in a particular character that is giving rise to this kind of attraction or repulsive consequences. That character is what is called as charge of the matter. Remember, I would like to repeat one important sentence, that during rubbing or because of rubbing, the character is not added. There is change in the character. Already the character is there in the matter, the material. This rubbing process is changing the character of that matter, and that character is what is our charge. And now, since here we have two cases, both plastic rubbed with silk or rubbed with wool, we have seen the case of repulsion. Here we have seen the case of attraction in the second example. So again, observation and drawing conclusion, which is the basis for our science. The study of science is entirely based on this observation versus conclusion. Now with this observation, we can conclude that the character which we have called charge is not one type, but charge is of two types. If it were only one type, then we have only one of the cases. Either we see the case of repulsion every time with everybody, or attraction every time with all types of material. But now, since we have taken it is two types, two consequences of attraction and repulsion, the conclusion can be the charges are of two types. Now, when there are two types, there should be some naming, right? and the naming is given as one type of charge is called as positive charge, and the other category, the other type of charge is given the name negative charge. So positive charges and negative charges, two types. Now we begin with the basic study of charge. In the beginning we will do all the details of charge. In doing so, I will follow one particular sequence, and it may not be the same sequence as you come across in your textbook. Remember, we cover all those topics in your textbook and much more than that also. So don't just compare the sequence and feel like missing something. No, we are doing bigger details as well apart from textbook as well. Now let us see. What are the important things to begin with? When once we know that matter is made up of charge. Now, first to begin with, what is the SI unit of charge? SI unit of charge. When it comes to the question of units, remember, always the units should be from known to unknown. Since this topic of electricity is new to us, in the beginning I will mention each and every new unit. But in the journey of the coming weeks, it should so happen that next time it should be from known to unknown from your side. If you are successful in that, trust me, your approach for numericals, your approach for any questions, you will start feeling ease. This is step one. Unit, you never use your memory. Maybe memory for only few things. Later, for each and every parameter, new parameter that appears, you have to write the unit. Make a huge practice of this. In the beginning it may be a bit difficult, but you just continue your practice, you will be master at writing your units, and then you will find all that advantage. Now, SI unit of charge is Coulomb, C-O-U-L-O-M-E, Coulomb. Generally, we abbreviate it as, while writing, we write it as C-O-U-L, Coulomb. Remember, the C is small letter we have to write, or else we represent with the capital C as well. So SI unit is Coulomb, the symbol capital C we use. Now, we here make one statement, and after that, in the due course, we will have an explanation for that. But here you take only that statement that Coulomb is a SI unit of charge. But Coulomb is not a practical unit. What is the meaning of that? It is a charge, it is the unit of the charge, but the magnitude of Coulomb, the charge in the quantities of Coulomb, we very rarely encounter or come across. It is such a huge quantity that in all the practical cases, it is not possible. Like what? Supposing I say, what is the SI unit of mass? kg. Yes. Supposing if I ask you, what is the mass of an ant? What is the mass of an ant? What is the size of an ant? Then definitely we don't use all these SI units like kgs, centimeter squares or meter cubes. Is it not? So when it comes to the units, we always make use of practical units by using multiples or submultiples, which is very familiar for you in your first PE. So since Coulomb is not just a practical unit, in most of the cases what we come across is micro Coulomb, which means 10 rise minus 6 Coulomb, or nano Coulomb, this is 10 rise minus 9 Coulomb, or pico for 10 rise minus 12 Coulomb, or sometimes it may be milli as well, 10 rise minus 3 coulombs. So all these submultiples we will use in expressing our practical units. So when you are reading the value of charge, this submultiple will be very important. Most of the students, what they does, they say 5 microcoulomb charge. When substituting the right 5 and they forget that submultiple micro, 10 raised minus 6 is forgot. And it makes all the difference, it makes a big difference in the final answer, right? So multiple, submultiple is a very important thing to remember. Now, one more thing, and of course why Coulomb is such a big unit, practically why it is not possible in most of the cases, we'll discuss this in the latter part. Now, in physics, whenever we introduce a term, a new parameter, we always look at it, whether it is a scalar quantity or vector quantity. And this is very, very important, I am telling you. Every time, whenever you come across new parameter, your first question should be, what is the SI unit of this parameter? Second one, what are the different units that we can write? Not only one unit, but different units that we can write. And the second, at the second level, you will see whether it is a scalar or vector. If it is a scalar, it doesn't matter much. But if it is a vector, what is the sense of direction? How to represent that vector or how to draw that vector is an important practice for the student. If we simply always look at the English part of the physics, when I say something as a definition, if you only see that English part, maybe for our unit examination, maybe for our term examination, maybe for our board examination, we may feel bit ease. Even in that also, most of the students you always keep on complaining about one particular thing, how to do problems. Is it not? How to do problems, what type of problems, how to do. Even if some of the students solve, not confident whether the answer is right or wrong. Why all these things coming in such a big manner? Because of, see, complete lifestyle. How we approach a particular subject is very, very, very important. And that is why, with respect to the units, I have told you step 1. If you are very good at writing your units and also relating different units, yes, your approach has started and your first few steps already started in the journey of this approach of examples, problems, solving, etc. Second level comes understanding the scalar natures and vector natures and how to draw vectors, such a thing. Therefore, now we put the question here whether charge is a scalar or a vector, and our answer is charge is scalar. It is a scalar. Charge is scalar. And do remember, generally when we represent a scalar, we always try to write the magnitudes. Now when it is the case of charge, we have both positive charges and as well as negative charges. Now here itself I give you one very, very important point to remember. Right, what is that? Supposing when we are doing examples, charges are given with positive charge and a negative charge. Sometimes all positive charges, or sometimes all negative charges, or sometimes both positive charges and as well as negative charges. This is what we call like charges. All charges only one type. We use that word like charges. All being charges with a different nature, we call them as unlike charges. So in any given example, whether you are given like charges or unlike charges, whether we have to use that positive sign or negative sign of the magnitude in the calculation. Suppose somewhere you got Q1 plus Q2, Q1 plus Q2, or in other case you got Q1 minus Q2. Now, whether I have to substitute that negative value of charge or positive value of charge or negative not to be used, all such cases will arise. Definitely it arises. Now, when right time comes, you will understand. There I will tell you where to use this positive or negative signs, where to drop those signs. So these are all essential things. Charge is a scalar quantity. Now here it comes. Now, most important points today now I am discussing. Characteristics of charge. Characteristics of charge. Very important 2 mark questions will be there, 1 mark questions will be there. You will find all 3 marks questions and so on. So now follow this discussion for another 10 to 15 minutes. Each of the character with every line follow carefully. At the end, I will pose some 5 to 6 questions. Whether you find your answers or not, you tell me. Now, the first character. Characteristics of charges. The first character which we have discussed earlier already is charges are 2 types such that like charges always repel, unlike charges always attract. This is the first property, first character. Like charges, shall I write it? Yes. Like charges always show repulsion, and unlike charges, they always show attractive nature. Attractive nature. That means that there is a force of interaction between 2 charges. Whenever 2 charges encounter, like or unlike, they have an interactive force, which will be a very big title which we'll do in our second session. That force can be either repulsive or attractive depending upon the nature of the charge. Now, the second one, the most important one, I write it as quantization of charge. Quantization of charge. We'll give some very important details, statements regarding quantization. Let us see this term quantization. See, this is not conservation, this is quantization. Generally, students have a kind of confusion between conservation and quantization, right? Conservation always refers to the total entity being always the same, that refers to conservation. No dissipation, no loss. If it is lost in one form, it will appear in other form. This is what is the nature of conservation. Now, what is meant by quantization? See, quantization in physics especially, we come across some 3 to 4 very important cases of quantization. What is meant by quantization? Right? Quantization is existence in discrete quantities. Existence in discrete quantities. Discrete means exactly a kind of opposite to the nature of continuity. The opposite nature of continuity is what is called as quantization. How to understand this? Supposing if I consider a material like this, we will find, at least apparently for our naked eye, we will find it as a continuous distribution of mass. Continuous distribution of mass you will find, supposing. It's a very, for simple understanding I am showing you this, right? What is that? Suppose if I take this matter, we find it as a continuous distribution of matter, at least for our naked eye observation. Apparently I am telling you, naked eye observation, it appears to be continuous distribution of mass. Whereas, suppose if I take grains, suppose I take wheat, or suppose I take rice, then if you take some quantity of that grain, what do you observe? you will observe them as made up of small entities, small elements, each of them which we call it as a grain. There we don't find the continuous nature. There you find each grain, 1 grain, 2 grain, 30 grains, 300 grains, like that. That kind of grain nature is what is called as discrete nature. So quantization always refers to existence in discrete quantities. Now, what is quantization with respect to charge? Now, first let us see. If you are now understood the concept of quantization, let us come to quantization of charge. Now, for quantization of charge, I will do it as two statements, A statement and B statement. First, according to this quantization, we write electronic charge is the fundamental charge. Electronic charge is, I am using one term here, fundamental charge is the fundamental charge. Don't say A. I am using the definite article, see here, the fundamental charge. I am now underlining electronic charge. What is meant by electronic charge? Charge of electron. In fact, the modern electron theory is one important understanding of the entire affairs that we will now discuss, which we will do in our next session with big details, right? Here I am making use of some of the terminology. Charge of the electron is taken to be the fundamental charge. This is an English statement. What is the meaning of that? Fundamental here refers to the smallest charge that exists in nature. If I call small e the charge of electron, this is a universal symbol. So wherever you come across in electricity, right, at least in electrostatics, small e the charge of electron, the universal constant, this is the fundamental charge, means this is the lowest or this is the smallest charge that exists in nature. We cannot have a charge which is less than that of electron. Now here, this E, the fundamental charge, the magnitude is given by 1.60292. It's a big number. Better if you remember. You can remember this as a phone contact of your friend, of your love, or of your enemy, whatever. Whichever is easy for you, try to remember. 1602912. Of course, I have a decimal here. 1.602912 into 10 raised minus 19 Coulomb. SI unit is Coulomb. Look at this number. Of course, every time we don't make use of that big number, always we write it as E is equal to 1.6, only 2. One decimal if we consider 1.6 times 10 raised minus 19 Coulomb. For all the practical cases, we take that only one decimal, right? 1.6 into 10. Look at this multiple 10 raised minus 19, which speaks of the extent of the smallness or extent of the quantity, how small it is for the electron. 10 raised minus 19, unbelievably small number, right? Now this is a part of our quantization, electronic charge, fundamental charge, and you need to remember this value of E. 99% of the examples will not be given E, where you need to use on your own. And the B part of quantization I am writing. According to me, quantization, of course, it can be given as a single statement, but according to me, both A part and B part happens to be the complete quantization principle. Now the B part says, now I say Q. Maybe I have not mentioned. Now onwards, chart we use this symbol Q, whether it is capital Q or small q. Maybe I have not used it earlier. Yes. So what will be Q referring to in our electricity? It is symbol for charge. Now Q is what is charge on a body, charge on a particle. This is what is the terminal. Charge on a body, charge on a particle. Now this B part I am writing, just make it more legible. Charge on any body. Shall I write it in the English statement? Yes. Here now I am writing. Charge on any body. I can call it any material or particle. Charge on any body is always an integral multiple. See, English is very important here. I used one term, integral multiple. Let us see what all those details. Integral multiple of the fundamental charge, which is electronic charge. Integral multiple of fundamental charge. Generally, this is only written as quantization. But I ask you, first write this part and then you can write this part. Charge on any body is an integral part of fundamental charge. Now let us write it symbolically. Symbolically, what the meaning it carries, right? And they, remember, whenever we are representing anything in terms of symbols, you call all of them as formulae equations. One more time, I remind you, in physics at least, we don't have formulae. You can call these expressions as formulae with respect to mathematics, but not in physics. They are formulae, yes, of course, you leave it aside, but more than that, all these formulae, any of the equation always refers to one definition or one law or one principle or concept. Therefore, as a student, when I approach physics, my approach should be slightly improvised, better from that of my approach towards mathematics. If I approach both the subjects in the same manner, definitely physics becomes tougher. In fact, it is not possible to learn the physics. We may learn some English part of the physics and we may learn some mathematics part of physics. But the soul, which we call physics, will be understood if our approach is definitely improvised over mathematics. Right? Now, let us see what is the quantization, how we are representing it as an equation or a formula. Q, charge on a particle, charge on a conductor, charge on a body. When we call this Q is equal to this N, a small n I am writing, times E, N times E, of course along with plus or minus sign. Plus or minus sign. Each and everything has its own significance. Q is equal to plus or minus NE. Q refers to charge on a body. In fact, still better statement would be charge on a conductor. Since I have not made use of the terminology conductor, insulator and all, simply I am calling it as a body. Maybe it's a wrong statement. Let us call it as a conductor in the latter part, the charge. N here is an integer, it is said. What is meant by integer? Yes, it is either 1, 2. This is what is integer. 1, 2, 3. You call natural number, right? Natural number. 1, 2, 3, so on. So we can have a case where Q is equal to 7E. Suppose if I write plus. What is the meaning of that plus and minus? We will come back to that. Supposing if I see Q is equal to 7E. Possible? Yes, it is possible. Suppose if I say Q is equal to 8E, 9E. Yes, it is possible because all these numbers are integers. Suppose if I say Q is equal to 7.9E. No. Fractional values of E does not exist in nature. Any charge on the conductor always an integral multiple of an integer value. Q is equal to plus or minus NE. Now, The significance of positive and negative sign I will take up in my next lecture, because there we will understand the modern theory of electron. To understand this charging and all, we'll have some discussion about that modern theory of electron. There once again I will come back and I will explain you what is the meaning of this positive sign and negative sign. So Q is always now. When we said this about the quantization, the most important point, I am writing it as a star mark to all of you remember. We have given the statement for the quantization and also a kind of expression. This expression itself you will have simple examples. How? What is LHS? Charge on a conductor or a particle. E, charge of the electron, which we have given the number. N of force. And therefore here there are two variables. One is Q, another is N. E is a constant value. Therefore, knowing the value of Q, finding N, or for a given value of N, finding the value of Q. Here comes your 1 mark or 2 mark questions. Even it can be a CT or a NEET question as well sometimes. If not directly, in one particular example, we will make use of this in the substitution at least. So got your principle. Now, star mark I am giving you. Why? Because you see, supposing if I say Q is equal to 1 Coulomb. Q is equal to 1 Coulomb. Here if you substitute that N value is equal to 1 by E, right? Q happens to be 1 Coulomb. Whenever you are reading the magnitude of the charge, please make sure what is the multiple or submultiple that is there. Because most of the students miss that submultiple and mess up with the answers. And that is why multiple, no multiple, submultiple here. You see 1 Coulomb, therefore N is equal to 1 by E. E value 1.6 into 10 raised minus 19 that we have taken. Therefore this 1 by E value, again I am giving you a value which will be a kind of constant. Wherever we come across 1 by E, you please substitute this number. This number is 6.25 into 10 raised 18. Look at that number again. 10 raised 18 is the multiple. 1 by E value 6.25 into 10 raised 18. So those many number of electrons, if all the charges are added, that is what happens to be 1 Coulomb. Now for any other submultiple like 1 microcoulomb, 10 nanocoulomb or 20 picocoulomb, that multiple also will be taken and this number will then decrease. So this is one important thing. Now we understand why Coulomb is such a very big unit of charge and it is not practical unit. Earlier I have told you, we will have generally all those charges unless and otherwise in the most extraordinary cases, abnormal cases, we always have charges of the magnitudes micro, nano. Why not Coulomb's magnitude? Because look at this number 10 raised 18. So this is what makes Coulomb not a practical unit. Now, another star mark I am writing in every concept during our discussion. So when you are writing notes as well, do remember when you are following the classes, even on the YouTube, be prepared with your notebooks, pens and everything. Along with the teacher, you try to write. During that, you will find some special. So here I said star mark because when you record something continuously and everything written in the same way, it becomes monotonous. We don't feel interest or we don't find interesting, and that is why I tell you your representation on the notebook, in the notebook is very, very important. Star mark I have made so that when you look at that notes, you will find yes, something special is about this point. Now one more 3-star point now I am writing. Let me call this as a 3-star point. That quantization, which is the discrete nature of charge, discrete nature, grainy nature that we have told, remember? So the discrete nature of charge, this is applicable. Quantization, see the statement carefully. Quantization of charge is valid, holds good, 100% for microscopic levels of charge. In fact, quantization of charge is valid. You can write only for, I will write only for. Quantization of charge valid only for microscopic levels of charge, not to the macroscopic levels of the charge. What is the meaning of that? What do you mean by microscopic? How much we will call it as microscopic? Supposing we have a case where 100 electrons, 50 electrons, 20 electrons, this number is very, very small. In all such cases, loss of electron or gain of electrons, which we will understand in the case of electron theory, modern electron theory, there if the number is too small, like a few tens or at least a few hundreds also, this discrete nature of charge is valid. Whereas when the number is too huge, like 10 cubes, 10 by 6 or 10 by 10, which are the cases that we come across, in all such cases we don't find this validity of quantization is not applicable. How? Supposing if I say straight line, if you take a straight line, suppose if you take a straight line, we all know that straight line, though apparently appears as a continuous continuous entity, we know that it is made up of large number of very small entities which we call as points. So large number of points now giving rise to this straight line. Now the question is that point nature cannot be observed in the case of this straight line. Rather we can observe only this as a continuous entity. Now the question is that whether it is made up of points or not. Answer is yes. Though it is made up of points, it is not of discrete nature. Apparently we will find it only as a continuous entity. That is the same here in the case of charge also. Quantization is valid, 100%, holds good for microscopic scales of charges, but not for the macroscopic scales of charges. Now, the point is that one more start point that I would like to make regarding this quantization. Again, I draw it as some 3 start point for you. That there is one famous experiment, which is the Millikan oil drop experiment, right? A Nobel Prize winning experiment by Millikan, an American scientist, physicist. Millikan oil drop experiment is a kind of proof for quantization. So which of the experiments have demonstrated the quantization nature of the charge? If it is 1 mark question or 2 mark question, it is Millikan oil drop experiment that verifies or demonstrates this quantization. So this is about only 2 characteristics that we have defined. I mean the basic interaction, whether it is repulsive or attraction. And the second property is the quantization of charge. In our next session, we will continue with the more and more interesting characteristics of charge. Have a good day. Make good notes, and for any of your doubts, description box, the contact numbers of all your teachers are given. You are at your liberty to call your teachers anytime. Good day. Thank you.